Welcome to the review and preview in the CCG book, problems 853 to 859. Question 853 says the exterior angle of a regular polygon is 20 degrees. What is the measure of the interior angle of this polygon? Show how you know. So it doesn't matter what shape our polygon is, if our exterior angle is 20 degrees, the exterior angle forms a straight line with the interior angle, which equals 180. So if we take 180 degrees and subtract our exterior angle of 20 degrees, we get our interior angle to equal 60 degrees. How many sides does this polygon have? Well, if our interior angle is 160 degrees, we know that we can subtract that from 180. So we know that our central angle is 20 degrees. And to determine how many central angles we have, we know our central angles all add up to 360. So if we take 360 and divide it by 20, we can tell that our shape has 18 sides. Eight 54 says examine the triangle and line of reflection below. On your paper, trace the triangle and the line of reflection. Then draw the image of the triangle after it is reflected across the line. Verify your reflection is correct by folding your paper along the line of reflection. So if we fold our paper directly along this line, we can see that it should match up on the other side. Find the perimeter of the image. How does it compare with the perimeter of the original figure? So when we reflect it, the perimeter of both triangles should be equal. So in order to find the perimeter when we're working with a right triangle, we can use the Pythagorean theorem, a squared plus b squared equals c squared. So 11 squared plus 17 squared equals our c squared. So when we square 11, we get 121, plus 17 squared is 289, which gives us 410 is equal to c squared. The inverse of squaring something is square rooting it, and we get approximately 20.25 is equal to c, or our hypotenuse. So when we add up all of those sides, we would say that the perimeter is approximately, so when we add up those sides, we say that our perimeter is about, we use two squiggly lines, 48.25 units. It then asks us in letter C to find the measure of both of our acute angles. So when we are looking for angles of a right triangle, we can use SOHCAHTOA. And we want to use the most accurate angle measures that they gave us. So if we talk about this first angle right here in the upper left-hand corner, I'm going to talk about my adjacent side and my opposite side. So I'm going to use the tangent of x, or our missing angle, is equal to 17 over 11. We're looking for our angle measure, so you want to go ahead and type in your inverse tangent. Then type 17 divided by 11 in your calculator. And you get, it is approximately 57.09 degrees. So we can say 57.1 degrees. Then asks us also for our other acute angle. So when looking at this angle, our adjacent side and our opposite side switch. So we're again going to use our inverse trig function, but this time it's going to be 11 over 17, which tells us that the angle is approximately 32.9 degrees. 8-55 says find the coordinates of the point at which the diagonals of parallelogram ABCD intersect if B and D, B is at -3, -17, D is at 1559. Explain how you found your answer. So we're talking about a parallelogram, and it intersects if B and D are at these specific points. So since the diagonals of a parallelogram bisect each other, so diagonals of a parallelogram bisect each other, so they must intersect at the midpoint of line BD. So to find the midpoint of line BD, we can take our x coordinates and add them up. -3 plus 15 divide by 2, because that would give us the midpoint, which is 6. Likewise, we're going to do the same thing for our y values. -17 plus 59 divided by 2, which tells us that they must intersect at the ordered pair 6, 21. 8-56 says find the area of an equilateral triangle. An equilateral triangle means that all of our angles and all of our sides of our triangle are equal. They told us that our side length was 20. Draw a diagram and show all of our work. If our side length is 20, we can cut our triangle in half to notate the height. So I know that area equals base times height divided by 2 for a triangle. When I cut my triangle in half, I created a 90-degree angle, which tells me that this side is 10. If it's an equilateral triangle, I know that this side is 20. So I can either use the Pythagorean theorem, 10 squared plus b squared equals 20 squared, and solve for b, or I could use right triangle trig. Because I know that this is an equilateral triangle, I know all of my angles must be equal. So this angle would be 60, this angle would be 60, this angle combined would be 60, which would make this little piece 30. So you could use the tangent of 30 degrees is equal to the opposite, which is 10, over b is another method. Multiply by b to get it out of the denominator. So we have b times the tangent of 30 is equal to 10. Divide by tan 30. Make sure if you're using right triangle trig that your calculator is in degrees instead of radians so that you get the correct answer, and we get the height of the triangle, or B, to equal approximately 17.32. When you find the area of your triangle, you take 20 times that number, divide that by 2, and you get the area. So 20 times 17.32 divided by 2 tells us the area is approximately 173.21 units squared. When you talk about your units squared, make sure you look at your problem. And in this case, we should actually say millimeters squared would be more precise and accurate. 8-57 says a hotel in Las Vegas is famous for its large-scale model of the Eiffel Tower. The model built to scale is 128 meters tall and 41 meters wide. If the real tower is 324 meters tall, how wide is the base? If we set up a proportion, so we put 128 over 41, we set that equal to our larger real Eiffel Tower. We can then use inverse operations, multiply by 41 on both sides, so we get 128 is equal to 324 times 41 over x, multiply by x on both sides because it's the inverse of division. Divide by 128, and we get that the real Eiffel Tower is approximately 103.78 meters wide. So some of you may have viewed this as cross multiplication, which is true, but the reason cross multiplication works is because it's the inverse operation of division. 8-58 says, for each equation below, solve for W if possible. Show your work. So looking at question A first, if we have 5W squared set equal to 17, I can get W by itself by dividing by 5. So we now have W squared is equal to 17 over 5. The inverse of squaring something is square rooting it. So we get W is equal to plus or minus the square root of 17 over 5, which reduces to, if we type it into our calculator, positive or negative 1.84. When we look at question B, if we have 5W squared minus 3W minus 17 equals 0, I have multiple methods that I can use to solve. I can factor and use the zero product property. I could complete the square, and the method that always works is the quadratic formula. So x equals, I can label my A, my B, and my C. X equals negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. And when we type this into our calculator and simplify, we get x is equal to 2.17, or x is equal to negative 1.57. So make sure when you work that out that you accommodate for the positive and then the negative to get your two answers. Looking at letter C, we have 2w squared equals negative 3. The first thing that I want to do is isolate my variables, so I get w squared is equal to negative 3 over 2. The inverse of squaring something is square rooting it, so I get this is not a real solution because we have a negative underneath the radical, and we're finished. 8-59 is a multiple choice problem, and it says the triangles below are congruent because of. So looking at my triangles, these symbols right here tell me that my sides are parallel. If my sides are parallel and cut by a transversal, I know that my alternate interior angles are congruent. So I can also conclude that these alternate interior angles are congruent. So I cannot prove that two triangles are congruent based on angle, angle, angle. So I could just conclude that these triangles are similar, so none of these properties would prove they're congruent.